Welcome to Unit 6, Level 3 video notes. We're going to continue to exhibit knowledge of simple counting techniques. For our first example, a deck of cards has 52 total cards with 13 diamonds, 13 hearts, 13 clubs, and 13 spades. If I deal out 5 cards, how many ways could I deal out 3 diamonds and 2 spades? So we're looking for the total outcomes here, where I'm going to choose 3 diamonds and I have 13 to choose from. And then I'm going to choose 2 spades from 13. So this sounds like a permutation or combination. So take a time out. Does the order matter where it's a permutation of the way I deal these 3 diamonds out, or does it not? If you said combination, you are correct, because I don't care what order these diamonds are dealt in or the spades. But I know that I have 13 diamonds to choose from, and I'm choosing 3 of them where the order doesn't matter, so it's a combination. I just want a group of 3 diamonds, not the different ways they could have been dealt. And then my spades, I have 13 spades to choose from, and I'm choosing only 2 of them. So my total is 5 cards here, but I'm choosing 3 from the 13 diamonds and 2 from the 13 spades. So now what we're going to do is multiply these together. It's kind of like the number of choices times the number of choices, that fundamental counting principle. So that first 3 diamonds and the 2 spades, this is like your 13 choose 3, and this is like your 13 choose 2, where you're going to multiply them together in the end. 13 choose 3 combination is 286. And 13 choose 2 combination is 78. We're going to multiply those two things together, and we're going to get 22,308. That's how many different hands of 3 diamonds and 2 spades that can be dealt. These next 2 examples are the same, except this one says without replacement, and this one replacement. So we can talk about the 2 differences in it. To win Mr. Sorensen's lottery, you must first pick 2 numbers from 1 through 6 without replacing them and put these numbers in a particular order. Then you must pick 3 letters from A through E without replacement in the correct order. How many different outcomes are there for Mr. Sorensen's lottery? So here we're going to pick 2 numbers from 1 through 6. So 1, 2, 3, 4, 5, 6. So I'm going to have 2 numbers out of those. And without replacement means if my first number is a 5, then I only have 5 options for my next one. Or if my first number is a 2, then I'm going to have 5 options for the next one. And it could be a 3, it could be a 6. But I'm not replacing that 2 back in there. So what that would mean is I have 6 options for the first one. And then if I take one of those options away, I would have 6 subtract 1, which is 5 for my second option. That is really the same as 6P2 because it's counting all the different ways. I could have 2 then a 3 or a 3 then a 2. It's counting all the different ways I can rearrange those numbers. Now we're going to pick 3 letters from A through E. So A, B, C, D, E, there's 5 options, A through E. And then if I don't replace it back in, the first letter could be a B. Now I have 4 options for the second letter, and then I'll have 3 options for that third letter. So since I'm not replacing that first letter, I'll have 5 options, subtract 1. And then I'm not replacing those 2 letters, so I'm going to have 5 options, subtract 2. So what I have on top would give you the right answer. Now those 3 letters on top, that's 5 letters to choose from, and I'm taking 3 of them, and I care about ABC or ACB or BAC, all the different arrangements of those 3 letters. So either way, if you times these together, or if you multiply these together, you get the same answer. Let's do that. So there are a total of 1,800 different outcomes for Mr. Sorensen's lottery. Now, in order to win Mr. Sorensen's lottery, you must first pick two numbers from 1 to 6, this time with replacement. And we're going to put these numbers in a particular order. Then we're going to pick 3 letters from A through E, this time with replacement again, in the correct order. How many different outcomes are there for Mr. Sorensen's lottery? So just like before, let's make some slots to understand what we're going to pick for numbers and what we're going to pick for letters. Just like in the last example, we're going to have 2 numbers, 1 through 6. And similarly, we're going to have 3 letters, A through E. The first number can be a 1 through a 6. So 1, 2, 3, 4, 5, 6 options for that first number. Now, with replacement means you can have repetition. So if my first number is a 3, instead of taking it out and not replacing it, I can put it back in. So my second option could be another 3. So once again, 1 through 6, 1 to 6 is a success, so the number of options is 6 again. Then for the letters, there are not 26 letters, but only 5 because it said so, from A through E. So A through E are 5 letters. Because we are replacing the letters, that means I will have the options A through E again. So that's 5 options, and the third letter I'm replacing back in those 5, and I will now have another 5 options. In the end, we multiply. So please go ahead and do that. And we get 4,500 different outcomes for Mr. Sorensen's lottery this way. And that is significantly bigger than the one where we didn't replace because those options were still part of it, where this one we had to subtract each time. One last fun fact is that repeated multiplication is exponential. So 6 times 6 could have been 6 squared instead, and 5 times 5 times 5 would be times 5 to the third. And how you can put that into your calculator is 6 to the second times 5 to the third. So that's kind of a shortcut in a way if you know your exponentials versus typing all that in. So 4,500 is the answer no matter how you plug it in your calculator. Good luck with level 3.